Hello, audience members, guests, and friends. Welcome to the Robin and Robin Show. Today we'll be discussing one of my favorite things, rocks. Now, you all know what a rock is. But dare I ask, do you really know? If not, no problem. You've come to the right place. In short, a rock is a natural substance made of one or more minerals. And minerals are substances made of elements, either one element, such as gold or sulfur, or more than one element whose atoms have been joined chemically, like quartz. Quartz, or SiO2, is a very important rock-forming mineral made from the elements silicon, Si, and oxygen, O. Now, rocks themselves are usually classified in three main categories. These categories are based on how the rocks form. First, we have igneous. Then we have sedimentary. And lastly, metamorphic. For now, let's focus on the first category. Igneous rocks form from the crystallization of liquid rock. And crystallization occurs when super hot liquid rock cools and hardens. Now, liquid rock can exist in two forms, either as lava or as magma, depending on where it's located. Lava is found at Earth's surface, while magma is located beneath Earth's surface. But when either lava or magma cool and harden, they both crystallize and form igneous rock. Now, the exact type of rock will depend on a few factors, such as what chemicals are present, the amount of heat and pressure, and the speed at which the liquid rock cools. Being the rock hound I am, I'd like to look at two common igneous forms, basalt and granite. Basalt is actually the most common rock in Earth's crust. This dark, mysterious rock is made of tiny mineral crystals, and it forms at Earth's surface either after spewing from a volcano or running down the side of a volcano. In both instances, it cools quickly and hardens into rock form. This explains why volcanoes are typically made of basalt. But basalt also forms when lava pours out of a big crack in Earth's surface. And when this happens, along with rapid cooling, sometimes basaltic columns form. Likewise, other columns may form underground, yet still very close to the surface. Granite, on the other hand, forms deep below Earth's surface, where magma cools very slowly. This allows crystals to grow much larger, which means that you never need a microscope to see them. Granite is a fantastic building stone. It's great for countertops, and it comes in different colors depending on exactly what minerals are present. Now, most granite is primarily made of light-colored minerals like quartz and feldspar, but dark-colored minerals like mica or hornblende are also commonly seen. More on rocks when Robin and Robin returns. Welcome back to the second part of the show, where we'll be focusing on sedimentary rocks. For the most part, sedimentary rocks form underwater, as did layers of the Grand Canyon. However, there are some sedimentary rocks that form at or near Earth's surface. These rocks are classified as fragmental, organic, or chemical. And I'd like to look at these one at a time. First is fragmental sedimentary rock. This rock is made of sediment, or pieces and fragments of old worn-down rocks. And these particle pieces can be microscopic, like those of clay, or they can be easily seen, like sand and pebbles. They can even be quite large, like cobbles and boulders. But regardless of their size, these fragments must be naturally compacted and cemented together to form fragmental sedimentary rock. Let me give you an example. Shale. This rock forms when tiny clay-sized particles settle in a calm lake or ocean water. What I mean is that the particles collect on the bottom of the lake bed or ocean floor and gradually get compacted and cemented together. Another example is sandstone. Sandstone's made of sand, no surprise there, and some sand is so small that it's hard to see, while some sandstone is made of much larger sand particles. The point is, regardless of size, the sand is compacted and cemented underwater. Next, let's discuss organic sedimentary rock. This is made of once living things, or at least pieces of them. For example, organic limestone is made from the remains of tiny sea creatures. And here's another example that may surprise you. Coal. Yes, coal is indeed rock, and it's made from plant remains that have changed over time but have not been destroyed, meaning they're completely decayed. This brings us to the final category of sedimentary rock, chemical. This rock can form by either the evaporation of water, especially seawater, or by chemical reactions. For example, chemical limestone is usually not made from once living things, but it often does come from a limestone quarry where blocks of limestone are mined. And here's another impressive limestone formation inside a cave. I'm just showing off now. Now, when large amounts of seawater evaporate, rocks like rock salt can form. Here's a piece of rock salt that's made from the mineral halite. And yet another chemical sedimentary rock is rock gypsum. These sand dunes aren't made of your typical quartz sand. Instead, they're made from pieces of weathered gypsum. Okay, I think that's enough showboating from yours truly. Stay tuned for the third and final segment of Rock Types when Robin and Robin returns. During the break, one of our audience members gave me a special treat. It's a punk rock. Get it? Because of the hair and sunglasses? That's just too much fun. Okay. Our last category is metamorphic rocks. These rocks are different from igneous and sedimentary rocks because they form from igneous and sedimentary rocks. They can even form from other metamorphic rocks. Let me explain how this happens. Below Earth's surface, extreme heat and pressure can change rock by creating chemical changes or a tighter packing of a rock's mineral crystals. This packing can change a rock into another rock without melting it. Because if you remember, when liquid rock crystallizes, it can lead to the formation of igneous rock. But we're talking about metamorphic rocks here, so no melting. I like to think of it like baking. Baking involves mixing things together and putting it all in an oven. Then what comes out of the oven is not exactly the same as what went in. No melting. Just a mixture that comes out in a delicious new form. Now, there are two main types of metamorphic rock, layered and unlayered. An example of layered metamorphic rock is slate. And slate is just metamorphosed shale, which, as we discussed earlier, is a sedimentary rock made of clay particles. But while shale is very soft and brittle, slate is quite hard and durable. Why? Because metamorphism has strengthened it. In fact, some roofs are actually made of slate. Good roofs, too. But slate can be broken, as seen in this gloomy photo. Well, let's just hope that didn't come from somebody's roof. Now, another layered metamorphic rock is schist. This rock type is usually made of mica, and because of that, is quite shiny. It's a little known fact that mica grains are all lined up in a similar direction, giving it a smooth, sleek, and polished appearance. This, of course, serves as evidence that the rock was under a lot of pressure when formed. And yet another example of a layered metamorphic rock is gneiss. It's made of light and dark bands of minerals, and the crystals in gneiss are typically larger than those in schist. That sounded strange, so I'm going to say it again. The crystals in gneiss are typically larger than those in schist. Okay. The other main type of metamorphic rock is not layered, and a common example of this is marble. Marble is actually made from the sedimentary rock limestone, and rocks similar to limestone. And as you may know, marble is a quality building stone, which is why many statues are made of marble. Well, that's all we have time for today. But from me and my punk rock, stay cool, and we'll see you next time.